In this section, we're going to solve polynomial equations. So we're going to actually work with higher than quadratics, which is what we're used to. We're going to factor them and solve by factoring, all that good stuff. So let me first start with saying that this is going to be a little bit confusing. There's going to be a whole lot to it to start off. But once we get into class, we'll, obviously spend a lot of time. So it's kind of like the last one where there's a whole lot, but it'll get better as we practice. So just write the stuff down. So first thing that you have to know, solving a polynomial. What that means is you need to factor it, you set each factor to 0, and then solve each one for x. What I'm going to focus on in this video is just the factoring portion, because that's the hardest part. Once you've factored, the solving part is going to come pretty easily. So a couple of things to keep in mind. Even exponents are considered perfect squares. So even exponents being x squared, x to the fourth, x to the sixth. And that's because x squared is really just x times x. X to the fourth is x squared times x squared. And x to the sixth is x cubed times x cubed. And the laws of exponents tell us that we add our exponents together. 3 plus 3 gives you 6. 2 plus 2 gives you 4. 1 plus 1 gives you 2. So if you were to take the square root of x squared, that means what is it that's being multiplied by itself, in this case x. The square root of x to the fourth would be x squared, and the square root of x to the sixth is x cubed. Exponents that are multiples of 3 are perfect cubes. So x cubed is your first perfect cube, and that's because it's x times x times x. X to the sixth is a perfect cube because it's x squared times x squared times x squared. X to the ninth would be your next perfect cube because that's x to the third times x to the third times x to the third. So when you're doing cubed roots, so cubed root of x cubed, that gives you x. The cubed root of x to the sixth is x squared, and the cubed root of x to the ninth is x cubed. So these are just examples. They're not the only ones, just to kind of give you an idea of how these work. Okay, so here's a shortcut for some quadratics. This doesn't work for all of them, but if you have something, a perfect square minus, this only works for subtraction, okay, only subtraction. This does not work with addition. So if you have a perfect square minus another perfect square, you can split it up very easily. So this is kind of like an outline. It's going to be more like a template where you can just kind of fill the stuff in. So let's go ahead and look at an example. 16 is a perfect square. The square root of 16 is 4. Actually, hold on. Sorry, I screwed that up. Rewind. First time around, when you are factoring, you always have to start with taking out what they have in common first. So start with the GCF. GCF in this case would be 16 and nothing else. So factor 16 out. So that's your first step in factoring. When you do that, that leaves you with x squared minus 4y to the fourth. Now work with your perfect squares. So x squared is a perfect square because the square root of x squared is x. Okay, so if I'm looking at my template here, right here, the 16 just stays put, but then we're going to have something plus something here, and then that same thing minus that same second part here. Well, this is what's going to go in your A spot when you did your square root of x squared. So x goes here and also here. So then now we need what's considered our B part. So the square root of 4 is 2, so that's going to go here and here. And the square root of y to the fourth is y squared. So y squared here and y squared there. That doesn't really look like a 2 for the square. Sorry about that. It's kind of weird. There, that's better. So this would be your final answer here. So it's just a template. Take out your greatest common factor, fill in the spots. Now here's a second example. So again, greatest common factor, and in this case, they are both divisible by 8 and also by x squared. So I'm going to start with taking 8x squared out, which leaves you with x to the fourth minus 16, and then the x squared goes away. So leave your 8x squared in front. Now this is your a squared minus b squared. So the square root of x to the 4th is x squared. So this goes in your first spot, and then in your first spot in the second set of parentheses, one's plus and one's minus. Then we have the square root of 16, which is 4. So 4 goes here and also here. Now, this one we can't do anything with. However, if you'll notice that this is a perfect square, but so is 4. So we can actually go a step further because this one is another difference, meaning minus, of squares. So I can leave 8x squared. I can leave x squared plus 4. But now I need to work with this one here. So I'm going to do the square root of x squared, which is x, and I'm filling in that template again. So x there and there, plus and minus, and the square root of 4 is 2. So 2 here and 2 there. And this would be your fully factored form of this original problem. Okay, so now we're going to deal with cubes, so a cubed problem. First thing is to memorize the word SOAP, and SOAP meaning same, opposite, always, positive. And so the way that those apply is you're looking at the signs. So if your original problem is two cubes being added together, the first sign is the same as this sign here, the second one is opposite, and the third one will always be positive. So if you're doing a difference of a cube minus another cube, this is the same as your sign here. This one is opposite, and this one is always positive. Okay, so we're going to use those templates and kind of fill everything in. So again, first thing is always to look and see what the GCF is. In this case, our GCF is 1, so we can't take anything out to begin with. So what I'm going to do is jump right into the fact that this right here is an a plus b, or a cubed plus b cubed. So we have to know what is our a, what is our b, so we can fill in our spots, right? So what we're going to do then is take the cubed root of 27, so the cubed root of 27, which is 3, and the cubed root of x cubed, which is x. So together, 3x is going to be your a term. Then I'm going to repeat that process for b, so the cubed root of 8, which is 2, and the cubed root of y to the 9th, which is y cubed. So together, that's your b term. So 2y cubed. So I need to fill in this template here. So a plus b in the first set of parentheses. A is 3x, and I'm adding to that b, which is 2y cubed. Then we fill in a squared. Well, if a is 3x and we have to square it, it'd be 3 squared, which is 9, times x squared, which is x squared. Then we do opposite sign, and then we do a times b. So a times b, 3 times 2 is 6, and x times y cubed. Then we do an always positive, b squared. So we're squaring this term here. 2 squared is 4. And y cubed squared is y to the 6th. And there's your answer. So this is your factored form of this original problem here. Okay, now let's do a difference of cubes, just a different pattern, but still the same idea. So this is still a cubed minus b cubed. Our GCF is 1. We don't have anything in common, so we jump right into doing cubed roots. So the cubed root of 64 is 4, and the cubed root of x to the 12th is x to the 4th. So together, these make up your a term, which is 4x to the 4th. Your second part is to deal with your y cubed here, so it's just this cubed root of y cubed, which is y, and so that is going to make up your b term. So fill in your template. We're dealing with this one over here. A minus b first. So we said a is 4x to the 4th minus b, which is y. Then we move into a squared, so we have to square the 4 and the x to the 4th, so 16x to the 8th, plus a times b, so 4x to the 4th times y, plus b squared, so plus y squared. And then that would be your answer for that. That's your factored form there. Okay? All right, now there will be times when you can't factor the polynomial, which would mean that it's prime. So what you would do first is look at your GCF. For this example, just 1. They don't have anything in common. So, okay, so then we look, is it a perfect square perhaps? Well, it's not, because neither of these exponents are even, so it can't be a perfect square. Second is, do we have perfect cubes? Well, for the x cubed we do. We can do the cubed root there and get x, so that's a perfect cube. Okay. But as we move into this one, where we try to do the cubed root of 5, that is not a perfect cube. So we can't take out a GCF. It's not a perfect square. It's not a perfect cube. So there's absolutely nothing we can do. It is not factorable. And anytime that you say that something is not factorable, that means that it is prime. So that's what you would write, is that it's prime. All right, so one more example, and then we're all done. Okay, now look at this one. This is like super crazy chaotic, right? But there will be times when things have all these terms, but you can still factor it. And so what you do is you do this thing called factor by grouping. And so what you want to do is group together your first terms here and your last couple of terms here. And make sure you leave this sign in between, and then if this was a negative, it would need to be here with your y plus or y to the 5th. So what we do now is take out our GCF. So you'll see that every single one of these has an x cubed, so we can take that out, x cubed, which leaves us with y squared minus 8y plus 16. Then we have a plus sign. And what do all three of these have in common? Well, these three all have y cubed in common, leaving you with y squared minus 8y plus 16. Now notice how at this point right now, these two things are exactly identical. So because those are identical, what I'm going to do is group together what's on the outside. So I'm going to pull the x cubed and the y cubed together. I'm going to group them, x cubed plus y cubed. And then I'm going to write that the fact that these are both being multiplied by y squared minus 8y plus 16. Now from here, this is a sum of cubes, so we have to do our a plus b times a squared, same sign, opposite sign, so minus xy plus, because it's always positive, b squared, so y squared. Then we need to factor this one as well, which comes out to be y minus 4 times y minus 4. And so your final result would actually be x squared minus xy plus y squared, and then we would do y minus 4 squared is usually the way that you will see this, and this would be your final answer. And so just to shorten up the video, I kind of flew through this one a little. So we'll work through it again when we're all together so you can kind of see how things fell into place. But making sure that you have this done is going to be the most important part of, this whole thing. So make sure you have everything written out, and we will practice, practice, practice.